Illustrative Math, Algebra 2, Unit 6, Lesson 2 is called Revisiting Right Triangles. This lesson is basically a review from geometry class about sine, cosine, tangent, and the Pythagorean theorem. All right, our warm up. What do you notice? What do you wonder? Go ahead, pause the video, and write down some things that you might notice or wonder. All right, I pre-typed them here, so we'll just kind of go through them. I noticed that it's a right triangle, or even more specific, you could say ABC, triangle ABC is the right triangle. The hypotenuse of the right triangle has length of C, and it's also the radius of the circle. The hypotenuse is the longest side, so C has to be greater than A and B, okay, because these are called legs. Pythagorean theorem would apply to this triangle. A squared plus B squared equals C squared, so it's always leg squared plus leg squared equals hypotenuse squared. And it appears that the measure of angle A is less than the measure of angle B. It looks a little narrower here. Angle CAB is narrower than ABC. We don't know for sure though, but that's just something I'm noticing. Another thing, angle A and angle B have to be complementary. Why? Because the sum of the angles in a triangle equal 180. So we know that angle A plus angle B plus angle C, which is 90, add up to 180. So when I subtract 90 from both sides, we get angle A plus angle B equals 90. All right, you could draw other right triangles inside the same circle with radius C as the hypotenuse. So, if I go here, here's my right triangle. I could draw right here. Same idea here. We have the same radius here, so that's C. And maybe draw one up here. So again, we know that this is a right angle. This is the same length because all radii on a circle are the same length. Because basically it's kind of like this is my radius, it goes all the way around, it's the same length there, it's the same length there. So I could draw a bunch of different triangles in there. All right, wonder. Is A the center of the circle? I'm just going to get rid of this. What are the measures of the angles and lengths of the sides? So, let me get rid of some of this stuff. I kind of drew a lot on here. So, what are the measures? How many degrees are the angles? What's the length of the sides on the triangle? Why is the triangle inside the circle? Why didn't we draw a triangle, maybe on the outside of the circle like this? Why didn't we draw a triangle? I got to make this a little bit longer. Maybe something like that. Why is the triangle on the inside of the circle and not like that? I don't know. Good questions, but we're going to find out a little bit about that today. All right, so a little bit of recall of right triangle trigonometry. You might remember this acronym here called SOHCAHTOA. All right, so what the SO stands for is the sine of your angle is equal to the opposite leg divided by the hypotenuse. The CA stands for cosine of your angle is equal to the adjacent leg divided by the hypotenuse. And then the TOA stands for tangent of your angle is equal to the opposite leg divided by the adjacent leg. So if you look here, the TOA is right there. The ka is right there. The so is right there. So SOHCAHTOA. So if I look at this triangle here, I can come up with 6 trig ratios. I could say the sine of angle A. If this is my angle, this would be my hypotenuse. This would be my opposite leg. And this would be my adjacent leg. So the sine of A is going to be 3 over 5. Cosine of A is going to be 4 over 5. And the tangent of A is going to be 3 over 4. Now, if I move my angle down here, my opposite and adjacent will switch. So when I go to do sine of B, it's going to be opposites all the way across the triangle. So if you look here, sometimes I've seen people, they like to draw an arrow to the other side. That's opposite. Okay, so the sine of B is 4 over 5, opposite over hypotenuse. Cosine of B is adjacent over hypotenuse. And then tangent of B is opposite over adjacent, so 4/3. Okay, we'll review there. So find the cosine of A, sine of A, tangent of A. So here's my A. This is my hypotenuse. This is my opposite leg. Again, opposite is right across. You see I draw my arrow there. The adjacent leg is right next to. So the sine of A is going to be 8 over 17. Cosine of A is 15 over 17. And then the tangent of A is going to be 8 over 15. So remember, I got my SOHCAHTOA. That's how I figured those out, okay? Sketch a triangle DEF where sine of D equals cosine of D and E is a right angle. What's the value of tangent D for this triangle? So I think it's going to have to be like a right triangle like that. So I'll put my E here at the 90. So then this is, let's call one of these D and one of these F. I think it's going to have to be like an isosceles, because if I say the sine of D, that's going to equal opposite over hypotenuse. It's going to be EF over DF. And then cosine of D is going to be DE over DF. But then because we see here that DE equals DF, we could replace that DE with, DE equals EF, We could replace that DE with EF. So now we know that their cosine of D is equal to cosine D because they're equal to the same ratio. So what is the tangent of D? Tangent of D is going to be equal to 1. How do I know it's equal to 1? Because think of it like this. Tangent opposite of D would be EF over adjacent would be DE. But we just said DE is equal to EF. So what I'm going to do is I'm going to replace the EF with the DE. And then anything divided by itself is equal to 1. Okay. So tangent of D equals 1. So there you go. There's your explanation. All right, if the coordinates of point I are 9, 12, what is the value of cosine G, sine of G, tangent G? Okay, so if this is 9, 12, this means that this piece is vertical, so that's 12, right? Because I went up 12, went right 9, so this side's 9. I'd have to do a Pythagorean's theorem to get my hypotenuse, which is C. So I'm going to do 12 squared plus 9 squared gives me 225, and then I square root both sides. So I get 15 equals C. So here's my angle right there. So this would be my opposite leg, adjacent leg, hypotenuse. So the cosine of G is going to equal 9 over 15, which if I reduce that, it's going to be 3 over 5. Sine of G is 12 over 15, which if I reduce that, it's 4 over 5. Tangent of G is opposite over adjacent, 12 over 9, which reduces to 4/3. Okay. All right, here's another triangle. It's in the plane. So here's angle D right there. So if I look at my grid here, this side's 5, this side's 12. So to get the hypotenuse, I would do Pythagorean's theorem. Which gives me 13. So the sine of D, opposite over hypotenuse, 5 over 13. Cosine of D is adjacent over hypotenuse. Tangent of D is opposite over adjacent. All right, here's a triangle similar to triangle DEF. What is the scale factor from triangle DEF to D prime, E prime, F prime? So just find a corresponding side. So like if I look here, this side here was 5. This side here looks like it's 15. This is 36. So you can clearly see that to go from here to there, we had to times it by 3. So scale factor is 3. And you could just say 5 times 3 gets me to 15. What's the cosine of D prime, sine of D prime, tangent of D prime? So for this one, I guess I'll kind of put a little mark there. So the cosine of D prime adjacent, I probably need to do Pythagorean's theorem here too. So I'll come down here. 15 squared plus 36 squared equals C squared. And get 39. So it's going to be 36 over 39, which if I reduce that down, it gets me to 12 over 13, which as you look here, it's the same there. So they're similar triangles, and they have the same ratio. Sine of D prime is going to be 15 over 39, opposite over hypotenuse. And if I reduce that down, I get 5 over 13, which, again, same ratio there for similar triangles. This one's obviously bigger because it goes, has different side lengths, but end up working out the same. Tangent of D prime is going to equal 15 over 36. And if I reduce it, it's 5 over 12. And as you look here, again, same thing. We get the same ratio there for sine, cosine, and tangent. All right, here's another triangle similar to DEF. So label it as D double prime, E double prime, F double prime. What's the scale factor? So my corresponding side here is the hypotenuse here. So I went from 13 to 1. So it would be times 13 times what number equals 1? Well, I can do algebra there, and I get 1 over 13. What are the coordinates of F? Explain how you know. Well, if I took 5 times 1 over 13, I would get 5 over 13. And then the x would be 12 times 1 over 13. That would be, this side would be 12 over 13. So the coordinates of point F right there, it would be 12 over 13 would be the x-coordinate, left, right. And then 5 over 13 would be how high up I went, okay? So since it's a similar triangle, we kind of already figured out that they're going to be the same, so I don't really need to do the ratios again. I could if I wanted to. Cosine of d double prime is going to be the same thing, 12 over 13. Sine of d double prime is going to be, again, 5 over 13. And the tangent of d double prime is going to be 5 over 12. So you can see how they match up. That matches up with that right there. And again, you could divide them if you wanted to, but it's going to just be over 1, so it's going to be the same thing. All right. So how could you use each of the tools or information given to determine the actual XY coordinates of point B? So we would need to find this length here. So I'd probably do Pythagorean's theorem. I'd probably say 0.5 squared plus B squared equals 1 squared. Let me erase that sloppy. So I'm going to get 1, whatever 1 minus 0.5 squared is. I get 0.75 square root. So I get 0.866 is the y coordinate. So the x coordinate we already know is to the right 0.5. So it's 0.5 comma 0.866. Now, here's the thing. I kind of rounded here. So if I didn't want to round, I would get b squared equals 1 minus 1/2 squared when I move that over. So it's really going to be 3/4. And if I'd rather have it be exact, square root of 3, I just leave it. Square root of 4, I can get a perfect square. So a better answer would be 0.5 comma radical 3 over 2. That would be better because it's exact. All right, so the coordinates of C are 0.96, 0.28. So that's the coordinates of that point. So I could think of it in terms of a triangle. Oh, these are two separate problems. That doesn't make sense. Whoops. These are two separate problems because the x coordinate here is 0.5. So you could think of it here. Let me draw. So maybe it looks something like that. So there's my right triangle. So here's my point right there. So you can think of it like this is 0.28 and this side is 0.96. And we can make a right triangle there. And we could get the hypotenuse there with Pythagorean's theorem. 0.28 squared plus 0.96 squared equals hypotenuse squared. I actually get 1. So right there, I guess it doesn't really ask me to do anything else. I could find anything I wanted, sine, cosine, or tangent there. So it'd be opposite over hypotenuse. So there's that. On this one here, I could find this value here, 0.5 squared plus b squared if this side is b equals 1 squared. If I keep it exact, I'm going to get 3/4. And then that's going to be square root of 3 over 2, because you square root the 3, square root the 4. That's how you get the square root of 3 over 2 when you take that square root of the 4. So the cosine of A would be adjacent over hypotenuse. This is my adjacent side. This is my hypotenuse. This is the opposite. So it'd be 0.5 over 1 for my cosine of A, which is just 0.5. Sine of A is opposite over hypotenuse, so radical 3 over 2. Okay. All right. Hope you enjoyed this video. Thanks for watching, and we'll see you next time.